I wanted to make a quick recording here about switches and inputs and some confusions that I think people are having. So first thing I want to talk about is pull-ups and pull-downs. And these are not, the idea of a pull-up and pull-down is not necessarily related to a switch. They can be used in lots of different places. It's more of a topic related to an input to a digital circuit. And it maybe doesn't even have to be digital, right? But in this class, we're mostly thinking about digital. And so if I have a chip over here, and this chip has some inputs, call them in1 and in2, and these inputs, if they have nothing hooked up to them, they're floating. And so that means we don't know, are they logic 0 or logic 1? So we can force them to a given value by putting a pull resistor that can pull up to a plus voltage, in which case it's a pull up, or a resistor that pulls down to ground, which is a pull down. So these are inputs with pull ups and pulls down. The pull up and pull down concept doesn't necessarily have anything to do with a switch, but it's related because we use them quite often with switches to force a known condition. Okay, the next thing, which really doesn't come up in any of the labs, is pulls and throws. And so there's some common terminology used with chips, or not chips, but switches, where you might hear of a chip or a switch being a single pull, single throw switch. So a single pull, single throw switch usually has a symbol like this, where this is the pull and this is the throw. So a single pull, single throw switch has one connection in and out, and then when you throw the switch, it makes the connection between those switches. And then a switch that is a single pull, double throw is a switch that might look like this, where you have a single throw per switch. It's a double throw. So we would have two switches, and each switch would be single pull, single throw. So here, and often these will have a dotted line between them to show that the throws are connected. So we have two throws, double throw, and each throw is a single pull. Okay, now you might have also a double pull, single throw. So here you have a single throw on your switch, and there's two poles that it could be at. So this is a switch that would have three terminals. So this is our throw, this is a single throw, and these are our two poles, double pull. Okay, and the switches can be more complicated than this. They could have triple pulls or triple throws, right? But these are just kind of some basic ideas to think about what's going on in a switch. Okay, now the third concept that I want to talk about here is normally open versus normally closed. Often you'll see normally open NO. And NC, normally closed. So there could be lots of different switch configurations that use normally open and normally closed. And so a switch that is normally open is a switch, and I'm going to use a single pull, single throw switch here that is normally open, would be a switch that is sitting in this configuration. And when you see normally open, that implies that there's some kind of spring mechanism inside this switch that will hold that switch open. And when you press the switch, the spring, if you let go of the switch, will spring it back open. So this is a normally open switch, and a normally closed switch is a switch that is sitting in this position and has a spring that is holding the switch closed, and so if you pushed up on it, it would open the switch, but when you let go, it would normally close it. And these concepts also, this SPST, normally open, normally closed, a lot of these also, these terminologies also apply to relays as well. They use those there because a relay is essentially just a switch that uses a magnetic field to open and close it. Okay, so when you're using a wire on a breadboard and you have a wire, let's say we had a configuration like this, plus 3.3 volts, and a pull-up to a switch that is connected to ground, and we've got this in a breadboard, and so we have our chip over here, and there's some pins on our chip, and coming off of this chip we have a resistor that is tied to the plus 3.3 bus. And we also have a wire that's coming off this, and we could hook it up to our ground bus over here. And so this wire has some insulation, and there's a lead sticking out, and we could put it into this hole. Okay, so is this normally open or normally closed? Well, it's such a simple switch, and there's no spring mechanism, so I would not call this a normally open, normally closed type switch. It's just a switch that can be either opened or closed, and there's no normal position because there's no spring that holds it one way or the other. And I mean, if anything, you could say that when it's open and it's floating in the air, it's normally open, but once you close it and leave it closed, it's normally closed. So it can be both normally open and normally closed because the mechanism that is holding it can do so in either position. And so if it can do that in either position, normally what you would call this type of switch would be a latching switch. And normally implies that there's a normal position that the switch is sitting in when a human is not interacting with it. But when you have a wire in a breadboard, there's really no normal position. So that's all I want to say on this topic, and I hope that clears up some mystery for some people and some confusion. And thanks for watching.